Hey, this is Yuri with TestCrackers. Happy to be with you. Purpose of my existence is to help you with this question. If n is 33 to the 43 plus 43 to the 33, what's the units digit of n? Now, in this video, hopefully I will go over ways in which this question could be asked, how to do questions like this problem, and finally, how to do this problem. In terms of ways in which this question could be asked, you could be flat out asked, what's the units digit of a certain number? You could also be asked, what's the remainder when something is divided by 10? That's exactly the same question. If they say, what's the remainder when x is divided by 10? We just have to figure out what the units digit of x is. For example, so if 57 is divided by 10, what's the remainder? Well, 57 over 10 is 5, remainder 7. And 7 is also the units digit of 57, right? 119, what's the remainder when this is divided by 10? Well, 119 over 10 is 11 with 9 left over. So the remainder is 9, and that's also the units digit. This is just another way of saying, hey, what's the units digit of x? You could see it that way. All right, a few things to note when doing these problems. Number one, we are in a units digit world. What do I mean by that? I want to take you out of your world that you're living in, place you into units digit world. Units digit world is where we only care about units digits. So 5 plus 7, what does that equal? If you said 12, you will be incorrect. 5 plus 7 is 2, because 2 is the units digit of 12, right? What is 6 times 9? 6 times 9 is 4, because 4 is the units digit of 54. The only thing that matters are the units digits in these questions, all right? We're living in a units digit world, and I am a units digit GMAT teacher. Okay, number 2, 132 cubed equals 2 cubed. 132 cubed is the same as 2 cubed. I know what you're thinking. Yuri, what are your qualifications to teach me this GMAT problem? Okay, well, I'm not going to answer that, but I will say that this is not as off as it looks. I'll show you why when we're living in a units digit world. So 1,234 cubed, we can do that first by squaring it. 1,234 times itself. First we have to square it, right? And then we'll multiply it again by 1,234. Well, to square it, 1,234 is the same as 1,000 plus 200 plus 30 plus 4. And this is the same as 1,000 plus 200 plus 30 plus 4. We're multiplying this number by this number. What we might be able to see is that the only combination of these things that ever produces a units digit is 4 times 4. Everything else is going to produce at least one 0 at the end of the number, like 4 times 200, that's going to have 2 zeros at the end. So that will not affect our units digit at all. What's 4 times 4? It is 6 in the units digit. And then when we cube that, we multiply this huge number that ends in a 6 by 1,000 plus 200 plus 30 plus 4. And again, the only thing that's going to produce a units digit will be this 4 and this 6 multiplied by together. And 4 times 6 is 4. So that means that the only numbers that matter are the units digit of the base. So in a question like this, we can cross off everything that's not the units digit of the base. In this question that we have, 33 to the 43 plus 43 to the 33, in the base, we just cross off everything except the 3, except the units digit. So I have 33 to the 43 plus 43 to the 33. I cross off the 3 and I cross off this 4. And this question is the same as 3 to the 43 plus 3 to the 33. The whole exponent matters, but the base, only the units digit matters. All right, patterns. The next thing to note is that we do not have to multiply 3 by itself 43 times and then 3 by itself 33 times to figure out what the units digit is. That would take forever and a half to get that done. What we could do is spot a pattern. And there are only 10 digits that could possibly be a units digit, right? There's a 0, 1, 2, all the way to 9. There's no other units digits out there other than 0 through 9 inclusive. In spotting a pattern, it's really helpful to know that the most work you're ever going to have to do is 4 digits. And because the highest number of digits in this pattern is 4. That's really satisfying. Now, do you have to memorize all of these patterns for all of these? Absolutely not. I would, however, probably write down this chart a few times and do it on your own so that when you get a problem like this and we have to know the pattern for 3, for example, and then we got to figure out the pattern for 3 again. Okay, we don't have to do it twice. That you could do it quite quickly so that you don't have to kind of struggle to figure out the pattern. So just, I would say, do this whole chart a couple times so you've got this down. What do I mean by this? Okay, so some of these digits, 4 of them, in fact, only have a 1-digit pattern. And that means that no matter what the exponent is, the units digit is always the same. Can you spot which 4 of these are? Okay, so 0 to the first power is 0. What's 0 to the second power? 0. 0 to the third? 0. That's a 1-digit pattern. 0 to any power is 0. You know what that means is that 70 to the 37th power, what's the units digit? Well, remember the 7 doesn't matter? So 0 to any power is 0. It's a 1-digit pattern, always that. Same thing with 1. 1 to any power is 1. 5 to any power is 5. And 6 to any power is 6. Like 5 squared is 25. 5 cubed is 125. 5 to the 4th, 625. Right, you get the idea. 5 to any power has a 5. Units digit, same thing with 6. 6 to the 1 is 6. 6 squared is 36. 6 cubed is something 6. It's got a 6 at the end. 6 to any power ends in a 6. So all of these 0, 1, 5, 6, there'll always be that number. Unfortunately, they're not tested that often because of that fact. Okay, now 2 of these numbers have a 2-digit pattern, and they are tested. And those numbers are 4 and 9. So 4 to the first power is 4, and 4 to the second power, see, 4 times 4 is 6. Now 4 to the third power, 6 times 4 is 4. It starts over again. So it goes 4, 6, 4, 6, 4, 6 forever. So it's got a 2-digit pattern. And the same thing with 9. 9 to the 1, of course, is 9. 9 times itself. 1 times 9. 9 squared, 9 times 9 is 81. So 9 squared is 1. And what's 9 cubed? Well, 1 times 9 is 9, and the pattern starts over again. So with 4 and 9, you have 2-digit patterns. You have 2-digit patterns. I'd like to take a little aside right now to talk about how to figure out what the units digit is when dealing with 4s and 9s. So there's a quick way. So 4 to an odd power will always be 4. See, 4 to the first is 4. 4 cubed is 4. 4 to the fifth is 4. 4 to the seventh, and so on. 4 to any odd power is 4, and 4 to any even power is 6. Because it only has a 2-digit pattern, just repeats, every other one is 4 and every other one is 6. And then the same thing with 9. 9 to the odd is 9, and 9 to any even number is 1. So if I said, what's 9 to the 1,236th, what would that be? Well, the exponent is even, right? And the odd exponent is going to be 9, and any even exponent is going to be 1. So 9 to the 1,236th is 1. It's a cool party trick. You could play at a party, I guess. Okay. Now, that's for 2s. There are 4 numbers that have 4-digit patterns, and that's what's left: 2, 3, 7, and 8. We're going to do 2, 7, and 8. You're going to do 3 on your own. So let's do 2. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. And 2 to the 4th is 6. Now, 2 to the 5th, in case you think I'm joking, what's 6 times 2? That's 2. Starts over again. So it has a 4-digit pattern. 7 to the 1 is 7. 7 times 7 is 9. 9 times 7 is 3. And 3 times 7 is 1. Now, so it's a 4-digit pattern. And then it repeats because 1 times 7 is 7. 8. 8 times 8. 8 to the first power is 8. 8 to the second power is 4. 8 to the third power. Let's see, 4 times 8 is 2. And 2 times 8 is 6. And 6 times 8 is 8. Repeats again. 3. You're going to do 3, right? 3 to the 1 is 3. 3 to the 2, 9. 3 to the 3, 7. 3 to the 4, 1. And now we start over again, because 3 to the 5, 1 times 3 is 3. So these have 4-digit patterns, and these are often, I think, the most tested because they're the trickiest. But this is the pattern. I would do this chart a couple times. Just do it out on your own from scratch. So that way, if you're given like 7 to the 156 plus 3 to the 11th or something, you would just do 7 and 3, the pattern for 7, 7, 9, 3, 1, the pattern for 3, 3, 9, 7, 1, and you would be good to go. And it would come quicker to you. Okay. So these are the patterns. Let's go on to how to solve a problem like this one. What is the units digit of 1,238 to the 17th power? 1,238 to the 17th power. Step number 1. We're living in a units digit world. We get rid of all the non-units digits in the base. So this question is only asking us, what's 8 to the 17th power? I mean, that's a hard question, but I'm saying it's easier than 1,238 to the 17th power. Next step is figure out the pattern for 8. Okay, what's the pattern for 8? Well, the pattern for 8 is 8 times 8 is 4. We have our 8, 4, 2, 6. It is a 4-digit pattern. Finally, what we're going to do is we're going to take the exponent, 17, and divide it by the number of digits in the pattern. So the reason for this is 8 to the 17th power, right? This is 8 to the first power. This is 8 squared. This is 8 cubed. This is 8 to the 4th. And then it starts over again. So 8 to the 5th is going to be 8. So what we really want to know is how many groups of 4 are there in 17? Like how many times does the pattern cycle through? And more importantly, what's left over? Or what's the remainder, right? And so rather than just kind of go 1, 2, 3, 4, okay, that's done. 5, 6, 7, 8, okay, that's done. 9, 10, 11, 12, okay, that's done. Rather than just put groups of 4 and cancel them out, we just divide 17, the exponent, by 4 because there's 4 digits in our pattern, right? And we see what's left over. So 17 divided by 4, that's 4. But more importantly, what's left over? 1 is left over. There's a remainder of 1. So what's the units digit of 8 to the 17? It's going to be 8. Because this, so we have a remainder of 1 at the very beginning, right? What's 1 divided by 4? 0, remainder 1. And then remainder of 2, and then a remainder of 3, and then a remainder of 0. And those are only options. When you're dividing by 4, the remainder has to be less than 4. So if you say 8 to the 17 is 4, remainder 1. So we have a remainder of 1. Therefore, 8 is our units digit. If we had a remainder of 2, 4 would be. If we had a remainder of 3, 2 would be. If we had a remainder of 0, 6 would be. The entire exponent is important. So if the exponent was like 105, you would divide 105 by 4. I think that's 26. Remainder 1. Remainder 1. And so the remainder would also be 8. Right? If you had 106, the remainder would be 2. And the units digit would be 4. So that's how you do it. Now you should pause this video and try n is 33 to the 43 plus 43 to the 33. Step 1. Get rid of the non-units digits. Step 2. What is the pattern? What's the pattern? Okay, well, we only have a 3 as a units digit, so we only care about 3. That's nice. And the pattern is a 4-digit pattern, and it goes 3, 9, 7, 1. So this is a remainder of 1, remainder of 2, remainder of 3, remainder of 0. Cool. Now, next step. Take the exponent, divide it by the number of digits in our pattern. So we take 43 and we divide it by how much? 4, because there's 4 digits in our pattern. I don't really care what the quotient is. I really care what the remainder is. So it's true that 4 goes into 43 10 times, but more importantly, the remainder is 3. What's our units digit? Remainder 1 is 3, remainder 2 is 9, remainder 3, 7. Our units digit is 7. Okay, cool. Now, we're going to do 43 to the 33. You got rid of that 4. 3 to the 33. What's the pattern for 3? 3, 9, 7, 1. Same pattern. Okay. What do? We divide the exponent by the number of digits in our pattern. Same pattern. Still has 4 digits. And we figure out what's the remainder. Let's see. 4 goes into 33 8 times. There's 1 left over. So our remainder is 1. So what's our units digit? Remainder of 1. Units digit is 3. Cool. What is 7 plus 3? You say 10. 7 plus 3 is not 10. What's 7 plus 3? Is 0. And that's our answer to this question. Some takeaways from today's video. When do you do this type of problem? Well, you're going to see exponents in the problem for sure, and you got to see one of these two type of questions. Either they're talking about units digit, or they're asking you what the remainder is when something is divided by 10. Either way, they're asking you the same thing, and you want to use this strategy. How do we do these problems? Well, The first step is for the base. You only consider the units digit. For example, 1, 2, 3, 4 to the 79. What are we going to do? We're going to cross off the tens, the hundreds, and the thousands place. We only care about that 4, and we care about the entire exponent. Step number 2, figure out the pattern of the base. So if the base is 9, then figure it out that 9 to the 1 is 9, and 9 to the 2 is 1, and it repeats. If the pattern is 2, you got 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, and 2 to the 4th is 6, and the pattern repeats. Whatever the base is, you got to figure out that pattern. Remember, it's either going to have a 1-digit pattern, a 2-digit pattern, or a 4-digit pattern. 3, you're going to divide the exponent by the number of digits in your pattern, and then most importantly, figure out what the remainder is in that quotient. So for example, if it's a 4-digit pattern and your exponent is 78, you divide 78 by 4 and you figure out what the remainder is. Here the remainder is going to be 2. Step 4, you want to pick the number in your pattern that corresponds to the remainder. So for example, if your base was 3 and the pattern is 3971, if your remainder was 1, we get a 3. If your remainder is 2, it's a 9. Remainder of 3, it's a 7. Remainder of 0, it's a 1. That's the 4 steps to solving this kind of problem. Hey, thanks for watching. Please like and subscribe. It would mean a lot to us if you could. Also, if you want some personalized instruction for the GMAT or the GRE, we offer live classes. They're small group. They're taught by top 1 percentile scoring instructors. And we have very lively and interesting classes. So check us out at testcrackers.org. Thanks very much and have a great rest of your day. Okay, the cost of clicking on this video is that you're about to watch me do this. We are living in a units digit world. I am a units digit GMAT teacher. You know that we are living in a units digit world. I am a units digit guy.